I got a Nintendo controller with a NES I bought recently, and it's in bad condition. Aside from being discoloured, it has lots of cracks in the plastic. I'm going to turn it into something unique. I'm going to make a wooden Nintendo controller. I'm using MakerCase, which is one of many free box design websites. You just need to enter your dimensions, material thickness, and kerf. Kerf is the material that is removed by cutting something. Each material and tool will have a slightly different kerf. Now I'm going to lengthen the box fingers so I can sand them down after assembly to remove the laser burn marks. Now that's done, I can design the engraving and button cutouts. I measured the controller up and took a bunch of reference photos. Now let's take the internals out of this controller. Are you working with material other than wood? Well, you're not a real one like me. Regardless, PCBWay have got you covered. With high quality 3D printing, CNC machining, sheet metal fabrication and injection molding services. They've also got fully customizable circuit boards starting from just $5 for 10 pieces. So if you're a hobbyist or a professional, PCBWay can get it done for you. PCBWay, prototype the easy way. This is one of the dirtiest controllers I've seen. It looks like those fake restoration videos that paint mud all throughout. I'll replace the button membranes as they're ready for retirement. I'm using Laser Engraver software to cut and engrave the wood on my Comgo Z1 10-watt laser. I experimented with a few different woods, from cheap plywood, pine and paulownia. The paulownia looked really nice after a coat of varnish, but it was just too flimsy. So I got my buddy to cut up some thin strips of pine. Time to burn. It looks great, but a dry fit of the box tells me that I need to make a slight adjustment to the fingers. I want a snug fit. I recut the side panels and the fit is perfect. Now I'll glue the box together with PVA wood glue. I'm not gluing the back panel on as I want it to be removable. I'll still put the back on so I can clamp it all together while the glue dries. Hopefully none gets onto the back panel and glues it shut. Now I want a nice cable to go with the wooden housing, so I'm going to replace the original black plastic one with some paracord. Removing the wires from the circuit board is easy enough, but the plug on the other end is a bit trickier. There are 4 clips that need to be pushed in at the same time, and since I don't have 3 friends, I made these plastic pegs to unclip them. I need to remove these terminals to run the wires through the paracord. Also, I was a bit rough with them when desoldering. I won't need to remove the pins on the plug side though. I need to take the guts out of the paracord so I can run the wires through it. Its climbing days are over. There are 5 wires for the controller, so it's much harder than installing a paracord on a mouse. I found the trick was to use a very small length of heat shrink and cover it in dust before feeding it through. Success! Nah, just kidding. I cut the paracord too short. Pro tip, don't measure out your length of cord based on its relaxed state. One last thing to clean before placing the pins back in their correct positions. For the controller end, I'll secure the paracord with heat shrink. Alright, let's check on this box. Awesome! Now I can sand off the extended fingers and remove the laser burn. And then lightly sand the whole box. Engraving deeper than desired means I don't have to worry about losing the detail from sanding. I cut some pieces for the internal supports, but they were too fragile. So I designed some larger pieces and utilised the Z axis on the laser by controlling the engraving depth. After sanding these, they look really cool. Obviously, I could have 3D printed the internal structures, but I wanted it to be all wood, so it won't give off any plastic fumes if it's engulfed in flames. I cut some pieces of dowel for the other supports. Now originally I thought I could get away with leaving the start select area two-dimensional. But it meant the buttons didn't stick out far enough. I couldn't have them further forward, as then they wouldn't be in contact with the circuit board. So I had to replicate the original recessed area. This turned out really good, as the engraving meant the edge broke off neatly. I need some support pegs to hold the cable in place, making sure they're extra sturdy. I glued all the pegs on the back plate, and now I can sand them all down until I get the perfect fit. It's looking good, I just need something to take the edge off. Because I'm soldering just the bare wires back on, I'll add some hot glue to support them. Alright, let's test this thing. I think I know just the club to use here. It's got to be a 3 iron, because this is a par 3.